Assalamu alaikum, this is Dr. Usman Sadek Pracha, and today we would be having our lecture number 28 of the subject Applied Quantitative Analysis and Practices. So in previous lecture basically we were discussing about the regression, its application in SPSS, and then we had a brief introduction of what is multiple regression and how basically its requirements are to be fulfilled, and what are the basics and foundations for multiple regression here. Likewise, we had a discussion on the equation of multiple regression and what's the difference between simple regression and multiple regression in this case. Likewise, then we had another discussion on what are the sample size requirements for multiple regression in this case, because the major difference between simple linear regression and multiple regression is that multiple regression involves more than one independent variable. And when we are involving more than one independent variable, then there is an issue regarding sample size, and there are many factors involved in that. So we would just have a brief recap of the content which we discussed in previous lectures. So coming to the point here, we just had a brief introduction of what is multiple regression, and here as you can see that here we basically use multiple predictors in multiple regression here, and several variables mostly are involved while evaluating such a model, and that's the main difference between simple linear regression and multiple regression in this case. Likewise, then we had quoted an example in which we just took a company which was a record company basically, and it wanted to predict the album sales from advertising. Now we had the data from 200 different sources, and outcome variable here was the album sales, and likewise the predictor variable here comprised of two independent variables. One was that the amount which was spent on promotion, or in other words the advertisement money, and then number of plays on the radio or airplay in this case. So here you can see the dependent variable here is the sales, and the predictor variable here are the advertisement money and airplay here. So this was the example, and we would be just commencing on that in order to have its application in SPSS. Then we had another discussion on the equation, that what's the difference between simple linear regression equation, and then what is the difference in multiple regression. So here basically in this case we can just have a look out at the initial part. We discussed about that before, that this is the part which was included in linear regression, and then the addition of additional variables basically was carried out when we had to basically perform multiple regression in this case. The error term here remains the same, and mathematical equation difference is very much evident here when we are comparing both types of regression. Similarly, then the interpretation again is the same as we had already discussed before, like B naught basically here as termed in simple linear regression also. This was the intercept. And again, the definition of the intercept in both types of methods is the same. Its intercept value is it's the value of y when x is 0, and then this is the point when regression plane basically crosses the vertical axis. So coming to this part, then we have our beta values, and beta 1 here is the regression coefficient for variable 1, as it is pretty much evident in the simple linear regression equation also. Then we have got beta 2 and beta n here, and in this case this is pretty much evident that beta 2 here represents the second variable, and it can go on to beta number of variables bn, and basically these beta values represent the weightage of the respective variables which are inculcated in multiple regression. Coming to the present example, we discussed this in detail, and we came to know about that through the 3D diagram here. But again, this is a scatter plot which is three-dimensional, and as we have discussed before, that three-dimensional scatter plot normally confuses things, because when we are including more than two variables, then the clear picture of the relationship in between them is sometimes not evident. So from the plane, it is clear that there is some kind of relationship which is existing between these three variables, but the exact situation is not pretty much evident from here. In order to have a pretty much clear picture, we have to then go on with further regression analysis, that's why. But normally the model basically here comprises and it does portray that there are certain relationships which are existing in between these three variables. However, we are not very much sure the nature of those relationships. So normally we use this methodology to have an overview, so that we can have a brief idea of whether to go ahead with further analysis or not. Now, then there was another important issue regarding sample size, because here you can see that simple regression can be effective with a sample size of 20. However, in this case, we pretty much are shown that minimum sample of 50 or 100 is required for multiple regression. The reason being so that the number of variables which are being included in multiple regression equation, they also affect our effectiveness of R square in this case. So in order to basically correctly predict R square, it is important that number of observations as per variable should also be considered. And in this case, as you can see, that the preferred this balance should be 15 or 20 to 1. And then again, if we are using some specific regression analysis techniques like stepwise, then we would have to add more observations. Again, the other important factor is the degree of freedom. Maximizing this degree of freedom also improves our model basically. So coming to the sample size considerations, now this chart gives us a very clear picture of how sample size determination should be made, how these variables which are independent play an important role in effectiveness of R square. And in this case, R square, by R square we mean that, let's say, for example, as we had just discussed before, that if we are taking a sample size of 20, then with two independent variables in the equation, we would only be able to track R square strength of minimum 45%. R square below that won't be able to be detected, so we cannot effectively measure R square in that case. So that's why, based on that, this is pretty much evident here that when we are increasing the number of independent variables, the R square, which is minimum R square, which basically is calculated and measured, would not be that much effectively and significantly calculated. So here minimum R square calculated is 56 in this case, which is not very much of a value, because this would lead to many discrepancies in the regression equation. So based on that, again, as we keep on increasing the number of independent variables for sample size of 20, then you can very much see that again we cannot very much effectively predict R square, and the minimum R square which can be detected keeps on increasing, which is not a very good sign in regression. So as we keep on increasing our sample size, then again the minimum R square which can be found significant keeps on increasing, which is a healthy sign for our analysis. Likewise, then we have got another case like the level of significance, which you can see here as 0.01 or 0.05. They also make a considerable impact on the criteria of selection of sample size here. So based on that, you can see that these independent variables with the same number of independent variable and same sample size, but with different level of significance, the minimum R square which can be calculated is quite much different. So that's why from this table it is pretty much evident that there are three things which impact the minimum R square that can be detected. And one is the sample size, the second is the significance level, and third is the number of independent variables. So sample size consideration is very much important when we are trying to run specifically multiple regression analysis. In simple linear regression, this sample size does not have that much of an importance as compared to multiple regression. So when we are considering simple linear regression, then sometimes even a small sample size of up to 20 can serve our purpose, but greater than that would have some significant issues. So sample size, basically when we are considering it, multiple regression procedures should be commenced with caution, and because multiple independent variables and their relationship with each other demand at least minimum anomaly from the side of sample size. So based on that, this is quite much important that this aspect should be covered very diligently in this case. Once we have gone through this issue, then the main important question arises is that what steps should be taken next after consideration of sample size. So here there are three basic tasks which should be accomplished in this case. First is that we should select a method And again, as we have discussed before, that in multiple regression there are many methods to calculate the regression variate, and it depends upon the situation, it depends upon the nature of data, it also depends upon the sample size and multiple other factors which can affect our decision to select the methodology which should be followed for regression analysis. Then again, the second most important issue is that we should assess the statistical significance of this overall model in predicting the dependent variable. Now here basically we should decide whether the level of significance should be 0.01, whether it should be 0.05, and likewise the whole assessment would be very important. In some fields it is necessary that we should keep assessment of 0.01 because the nature of the study is very critical and we want to be around about pretty much sure of what we are trying to conclude. So in that case 0.01 level of significance is suitable, and in fields like medical sciences this is pretty much important that such a level of significance should be pursued. However, in terms of for example business studies, where the studies are not that much critical as compared to medical sciences, then we do consider the level of significance as 0.05, which is tolerable in this field. So again, and this is quite important that when we are trying to select the method, we also be pretty much sure that what would be the level of significance we want to pursue. Once we have gone through that, then we have to determine that any of the observation may exert undue influence on the result. That means that we are looking for outliers. So we have to basically examine the data which is to be put in the regression analysis stage, and that's pretty much important here. So because though regression analysis is considered to be pretty much robust, but still there are influential observations which have an undue impact on the whole study. So this is pretty much important that the variables which are to be inculcated in the equation should be kept in view before commencing with in this case with the final analysis. So coming to this whole thing, then we have got certain methods which need to be discussed. Primarily there are three basic methods which are followed. One is called hierarchical method, the second is forced entry, and third is stepwise. So in case of hierarchical, the variables are entered within the equation order-wise, and the person who is experimenting this thing decides that in which order the variables are to be entered into the regression equation. Then in second type we are dealing with forced entry method, and in which all the independent variables are entered simultaneously. But in order to pursue such kind of method, this is pretty much important that the whole concept is founded on strong theoretical foundations, because without the theoretical justification it's not possible to enter all these independent variables simultaneously in the equation. Then we have got the third part, which is stepwise, and then here basically the predictors are selected based on their partial correlation and in fact semi-partial correlation with the outcome. And again in stepwise we can move forward or backward. These are further two types on the stepwise methodology. So these three methods basically are selected based on the theoretical perspective or theoretical requirement of the study, and each kind of methodology does yield somewhat kind of different results. So while pursuing these methods, this must be kept in mind that the theoretical perspective should be kept in view, the nature of results which are required for such study should be kept in view while choosing the right method for this kind of analysis. And also we would discuss later on that what are the relevant advantages and disadvantages of each methodology here. So coming to that part, we can have a look that what's hierarchical regression. And in this case you can see that in this case independent variables are entered in the regression model, and basically those independent variables are first entered in the equation in which for which we know their impact in previous studies. So these known predictors whose impact has already been tested in previous research, these predictors are preferred first and are first entered in the regression model. Also, this is decided based on the correlation of that specific predictor with the dependent variable, and also we keep in mind that what was the standard relationship intensity of that specific predictor with the dependent variable. So basically in this case this is pretty much theory driven. Then we have got new predictors, and these predictors are entered in a separate block so that we can observe their impact separately. And this is again another type which is enhanced with a term called block hierarchical regression. So basically in this whole methodology the experimenter makes the final decision. So experimenter, while making these decisions, basically keeps in mind what are the predictors which were entered first and what was the basis for entering them first in the regression equation, and it also keeps in mind what is the nature of new predictors which are entered in the regression equation in this case. So coming to the next one, what are the advantages and disadvantages. Hierarchical regression is termed as the best method, and normally it is based on theory testing here, and you can see that the unique influence of this new variable on the outcome, because in this case we have the advantage of keeping the previous variables or old variables as constant or as permanent in there. So we control the effects of predictors here, and while controlling these effects then we try to find out the impact of the new variable in the equation. So this is the first part. Then second is there's a discrepancy in this method, that it totally relies on the knowledge of the person who is executing these methods. So human error is there, it is possible, because basically it's not possible to have an ideal user to test all these based on ideal figures and statistics. So basically this is the weakness in hierarchical regression in this case. Then we have got another method termed as force entry regression. So in force entry regression all the variables need to be inculcated in the model simultaneously, and then the result obtained depend on the variables which are entered into the model. And again this part should be very carefully considered, because when you are simultaneously entering all these variables in the equation, then we have to keep in view these variables' interrelationship with each other, because that interrelationship also negatively impacts the final result. So a forced entry regression can only be pursued when we have got strong theoretical background to pursue such a method. So based on this thing, again, this is pretty much important that forced entry regression should be taken seriously, and these results can only be interpreted with the presence of a strong theory. Theoretical aspect here basically rules the selection, or rules the decision for selection of variables for forced and entry regression here. Normally, if we have decided to pursue this method, then we also have to care for the multicollinearity, because multicollinearity greatly disturbs the impact of independent variable on dependent variable here. So once we have gone through this methodology, then various checks need to be ensured so that the discrepancies of this method don't affect our results. So coming to the other method, which is also termed as stepwise regression, here the difference between this method and previous one is that these variables which are considered here are entered as per a specific mathematical criteria. So the software basically selects these variables in steps automatically. So first step is that SPSS looks for variable that explains the greatest variance in the dependent variable, and in order to do that, the SPSS in the background, it generates the correlation, the partial correlation and semi-partial correlation for this purpose. So in stepwise regression, basically this software is looking for the combination of variables who have explained the most part of dependent variable, or in fact which are contributing most variance in the dependent variable here. Obviously, from the name of this method, it is very much evident that the selection of variables will be in various steps, and again the most highly correlated variable first would be entered in the equation. But again, in this case, the researcher will not have any control of this process, because this selection of variables which are to be inculcated in the equation will be done automatically by the software. So this is also one of the discrepancy in this case. So coming to the second step, which is important, that when first predictor is selected, then the second one is chosen from the remaining predictors. Definitely that's the path which we have already discussed. But in that case, the semi-partial correlation methodology will be used for selection of second variable. In case of first variable which would be selected, that variable selection is based on full correlation, or pure Pearson correlation in this case. Once, let's say, we have selected one variable for that purpose, and it explains 60% variance in dependent variable, then the SPSS would look out for the variable, the next one, which would explain the remaining 40% variance, or what would be the most highly correlated variable, which would not only explain the most part of remaining 40% variance, but also be stable enough to be inculcated in stepwise regression. So in this case, the rest of the variables definitely would be selected based on semi-partial correlation. Now this semi-partial correlation, though, we have covered in our previous lectures, but we would just go ahead with that what is semi-partial correlation. Now the partial correlation basically is the relationship measure between two variables while we have to control the effect of third variable on both. So in this case, the semi-partial correlation is like that we have to measure the relationship of two variables, but we have to control the impact of third variable on only one of those two variables. So if I depict this diagrammatically here, so then you can very much see that if we are trying to find out the impact of correlation between two variables and there is a third one which is having correlation with both. So in partial correlation, basically we would try to control the effect of this third variable which has impact on both of them. So basically this whole phenomena will be controlled for partial correlation. But in case of semi-partial correlation, if we can just depict this again with the help of diagram, you can very much see that the third variable impact on this one variable will be considered in this case. So here basically we are considering only one variable impact basically which is being executed by the third variable here. So that is basically semi-partial correlation. So that's the main concept behind this semi-partial correlation here. And then we have got another issue, like let's say we want to explain this phenomena more. Then in this case it measures the relationship between the predictor and outcome and controls the relationship between the predictor and any other variable already in the model. So in other words, you can say that it measures the unique contribution of the predictor in explaining the variance of outcome. So we, in other words, try to find out the individual impact of that specific predictor here. That's the difference. So basically this is the main concept which is specifically followed in this case. So coming to the problems with stepwise methods, well, we have got issues that here the selection of variables would be purely based on mathematical criteria. So once we are selecting it on pure mathematical criteria, that means that we are not involving any theoretical judgment by the researcher in this case. So there is very much little interference of researcher here, which on the one hand is an advantage, but on the other hand it is a disadvantage as well. So these basically the selection of variables can be made on very slight differences, and though theoretically these slight differences may not matter, but based on these slight differences, the SPSS would be choosing which variable is to be inculcated first and which variable is to be inculcated on second step. So based on that, this is pretty much vital that there are several issues which the software can come up to during this whole mathematical criteria. So that's why this whole procedure cannot be left upon the software itself to decide, because there are many theoretical considerations which need to be considered before commencing with any other step. So based on that, we cannot just move ahead and let the software do all the calculations here. So that's why, because of this auto calculation aspect in this method is only recommended for exploration purpose only. Based on that, again we then come up to some very important interpretations, and in this case we can see that what's the difference between R and R square. We have already gone through that a bit, but here in multiple regression the concept is around about the same. So R basically is the correlation between the observed values of the outcome and values predicted by the model. Then we have got R square. Again, it's the proportion of variance which is accounted by the model, and the adjusted R square. Now here adjusted R square basically reduces the R square by taking into account the sample size. So basically also it depends upon the number of independent variables in the regression model. As we know that one of the discrepancy of R square value is that the greater the number of independent variables, then R square has the tendency to increase naturally. So based on that, this is one aspect which should be very carefully considered. In order to tackle such a discrepancy, this is vital that R square values should be adjusted in this case, and that's why another terminology is then introduced, which is termed as adjusted R square, and it becomes smaller as we have fewer observations per independent variable, and that's why whenever we are trying to interpret a model or its strength or its any kind of relationship, then we basically try to state its readings from adjusted R square instead of R square. So adjusted R square value is of prime importance while considering the whole model, and again you will see that in some models this proportion of R square as compared to adjusted R square is smaller. In some models it is greater, depending upon the nature of data which is being considered. So this interpretation of the value of R square while explaining the regression model is of primary importance, as we have seen that even the effectiveness of R square depends upon the number of factors, and even a sample size selection, a number of independent variables, and the level of significance. These are many factors which impact the R square value, and that's why even the tendency of R square of increasing as it is dependent upon the number of independent variables basically has a very great impact on this main interpretation of the model. So that's why this is very much important that adjusted R square is used in order to tackle such a discrepancy. So coming to another important aspect is the F-test, and we have already discussed this. There is a separate reading which is basically given by SPSS under the label of ANOVA, or analysis of variance, in which the whole model is basically displayed to us. And here basically the variance explained by the model in the form of SSR and then the variance explained variance of the error, basically, which is denoted by SSE, is displayed, and it basically tells us that how much significant our model is in predicting the values of outcome variable. So the F-test basically also has its significance value calculated, and obviously when we are trying to test any kind of value in this regression model, we have to check for its probability and its p-value as well, so that we can find out whether the p-value is less than 0.05 or not, so that we can assess the model in terms of its acceptance and rejection, and we can then answer the relevant question related to null hypothesis and alternative hypothesis. So the F-test is also reported, as we have discussed before, it's reported in simple linear regression, and again it is reported in multiple regression as well. So then the other important issue is how to interpret beta values, and again from here we can very much see that the beta values are related to the change in outcome which is associated with the unit change in the independent variable here. So coming to this thing again, there's a difference between beta values and standardized beta values, and we have discussed this in detail. Basically the initial beta values which are reported by the software at first are the values which are only measured in the same unit in which the original variable is measured. So that's why the beta values of one variable cannot be compared with the beta value of other variable in the same equation, because there is strong possibility that both the variables which are being measured they are measured in different units. So based on that we cannot basically assess that which beta value is more significant than the other. So in order to tackle this issue, these beta values are then standardized, and these values are then explained in terms of their standard deviation. So once we have standardized these beta values, and these values can easily be interpreted and they can easily be compared, and then we can say for sure which beta value is more important as compared to other beta values. So again, it's the interpretation, and specifically in multiple regression, these standardized beta values are of primary importance, because we are dealing with more than one variable. In simple linear regression, this thing is not of much use, because we have got only one variable at our disposal. So we don't have to compare that variable with others. So that's why even the report of that variable in standardized form is sometimes is not that much of importance. But in multiple regression, this is quite vital that the standardized beta values should also be reported. In fact, in most studies, in business research studies, the standardized beta values basically are only reported. The other conventional beta values are not reported at all. Reason being so that standardized beta values are of more important concern as compared to these beta values. However, these beta values do have some importance, and we do have to report both of these in our analysis. So let's come to an example in SPSS, and let's try to find out how results and how this whole multiple regression phenomena is carried out. So let's click on Analyze, and we go to Regression option here. We click on Linear, and while clicking on album sales as dependent variable, then we click on basically advertising budget as independent variable, and here you can very much see that the method basically here is pretty much shown here in this window, and you can see that presently the method which has been selected here is termed as enter. So I click on it, and a drop down menu appears, and in this case you can see that there are other methods listed here. One is stepwise, which we have just discussed before. The other is remove method, the forward method, backward method. So these are further subtypes of even stepwise regression as well. Enter basically means that we are dealing with forced entry method here. Now here basically when we are trying to perform hierarchical regression, then we have to give our variables in blocks. So here we just want to see whether in this case first what is the impact of advertising budget on album sales, and then while controlling for this first variable, then we want to access the impact of the remaining two independent variables on dependent variables. So first I mention this first initial variable in first block, then I click on next, and you can see that there is another block which is appearing as termed as block 2 of 2, and here you can see that we can click on the rest of the independent variables as airplay. Then there is another one termed as attractiveness of brand, which we may want to find out, and we click on that and select it. Again, both these variables impact is measured through forced entry method. However, as overall we are trying to deploy hierarchical regression method. So now here then if we click on previous, we can see that the block 1 of 2 is very much visible here again. So the main part is that we want to assess the impact of advertising budget with and while controlling for the rest of the two variables, and then we want to assess the impact of rest of the two independent variable while controlling for advertising budget. So we click on this statistic part. Again, we want regression coefficients as R-square chain, descriptives, part and partial correlation, collinearity diagnostics, Turbin-Watson, and here as you can see that as residuals reported here are standardized, so we can mention the case-wise diagnostics for standardized residuals, because as residuals which are calculated are unstandardized, they cannot be compared against what should be the minimum value and what should be the maximum value of residuals in this case, but that's why we standardize these regression residuals, and based on that then we can easily state that outliers which should be mentioned should be minimum 2 standard deviations. So here we click on 2 standard deviations as the basic definition of residual outliers here. Then we click on continue, and we can also click on confidence intervals here. We click on continue here, and then we also have to find the plots. Again here we want to find out the test the various conditions like homoscedasticity condition, the linearity condition, the in this case the independence of error condition. So we just plot the graph between z values of predicted value and z values of residuals in x-axis. We also want to know the histogram and normal PP plotting in order to confirm the linearity assumption. We can also click on produce all partial plots so that we can have a clear-cut idea of the behavior of individual variables residuals against each other. Then we click on continue and then we click on save here. Now here we have to go through various methods to see which kind of residuals need to be reported so that we can identify various outliers in this whole multiple regression. Now there are multiple values which are enlisted here which can be used to assess the outliers, and we will have a brief discussion about them in detail onwards. So we just leave this for the time being. We will run the analysis again next time, but with all these residuals included so that we can clearly know what are the outliers which are existing in this data set. So we click on continue here. And again we click on options. Again here you can see that we can select for the probability of f, whether its entry level is 0.05, and then we can include constant in equation, and we click on continue here. So we click on OK, and while looking for output here, you can clearly see the correlations which have been demonstrated here, and in this case the Pearson correlation is pretty much evident, and from here we can very much see that the number of plays have got the most important correlation, stronger correlation with album sales, and next is then the advertising budget. Likewise, the significance of these results is also portrayed along with the number of cases which are valid. Now here we would have a look at the results, and it is pretty much evident that in first result, the first model, you can see that it is enlisted here as advertising budget, which is used as a predictor, and the adjusted R square reported is 0.331. So 33% variance is accounted by advertising budget in this model, and you can see that the F value is also significant here. Then we look at the second model here, and we can see that its predicting power has increased while controlling for the advertising budget. The rest of the two variables are now played, and here you can see that by adding attractiveness of band and air plays, these two variables separately have a 33% impact on this model, which is pretty much evident from R square change. Now, R square change clearly gives us the idea of how much change the R square has incurred when we have put additional two variables and have controlled for the initial first variable termed as advertising budget here. So this second model is also significant here in this case, and the Durbin-Watson, which is applied here in order to check for autocorrelation or among the independent variables, and its ideal value is 2. The values closer to 2 are termed as satisfactory. So here we can term as satisfactory as it's 1.95. So overall, this model clearly depicts that both the models in which 3 variable impacts have been tested are significant. All the 3 variables have an impact on the album sales, and this gives us a brief idea of this model. So the rest of the analysis will be tackled later in the next lecture. So in today's lecture, basically we had a discussion on the various methods of multiple regression which are involved here, and basically we had an overview of these three methods which we discussed. One is the hierarchical regression, the second is forced entry method, and then third is stepwise method. So all three methods differ in nature, and their usage basically depends upon the nature of theory, the nature of data set which is to be considered. Then again, it's very much important that for each method we also have to consider the sample size, because specifically in stepwise regression method the sample size needs to be more. So again, all these methods have got their own advantages and disadvantages in this case. While considering the different aspects of these methods as we discussed, this is pretty much evident that each method cannot be termed as superior to another, because every method has got its own advantages and disadvantages here. Hierarchical regression method basically deals with the blockwise entry, which we discussed earlier in SPSS also, and in which we try to find out the impact of one variable while controlling for another. We had a discussion on what's the methodology involved in controlling these variable effects, and we discussed about the phenomena of partial correlation and semi-partial correlation in this case. While going through these methods, basically, we know that at first in hierarchical regression, partial correlation is considered, and then afterwards semi-partial correlation is taken into view while considering the impact of these independent variables on dependent variable. So once we had a discussion on this method, then we had a detailed point of view on forced entry method, in which we have to include all the variables simultaneously. Now this method has been the focus of attention in many research studies, and it has been specifically argued that forced entry method should only be considered when we are very clear about the theoretical perspective of the idea which we are pursuing, and also the data set should be taken into view. Because in forced entry method there is a high chance of multicollinearity occurring, and that aspect is not very much advisable in multiple regression, because it changes the nature of results there. Then we have got another issue with forced entry method, and in which again, as they are simultaneously entered, so we are disregarding the impact of any important variable or a variable which has a lesser impact, and we are just trying to see the equal weightage of all these variables in this case, which may become our disadvantage as well. Then comes stepwise method, which we discussed. In stepwise method, we had a detailed discussion on how these variables are entered stepwise, and how we have to assess the impact of each variable at each step. And again, the SPSS automatically calculates the correlation and the variances, and based on those correlations, those variables are entered in the equation and taken out. Based on that, again, the stepwise methodology is therefore totally computer driven, and researcher has got minimum interference in that, but it has been criticized for its mathematical nature, because the theoretical aspects are not very much addressed here, and the variables, the decision for variable entry can be based on very small differences among these variables, and those even small slight differences which the theory may not even consider. So that's why stepwise method basically is not very much advisable, in which unless and otherwise we have got very clear motive to pursue it. So these were the various problems with these methods which we discussed in detail, and likewise we also discussed that R and R square concept, which is round about the same as we have discussed in linear regression also. And then we had the discussion related to adjusted R square, why adjusted R square is a necessity and why it should be used. And then the beta values and how beta values are reported, and why do we need these standardized beta values in this case. So I hope you understand this lecture. Thank you so much. Allah Hafiz.